how to see the bright Andromeda galaxy shine overhead this week. Located about 2.5 million light years from our solar system, Andromeda is the most distant object visible to the naked eye. And this week, with the bright moon having left our evening sky, you'll have a chance to see the most distant object that can be glimpsed with the unaided eye, the Andromeda galaxy. The remarkable deep space object will be passing almost directly overhead between 7:30 and 8 p.m. local time. And here's everything you need to know about our celestial neighbor. Where to look, first of all. To find the Andromeda galaxy, first locate the Great Square of Pegasus, a landmark of the autumn sky. Then focus binoculars on the bright star Alpheratz, which is the upper left corner of the square. Don't have binoculars? Here are the best binoculars for stargazing. Basically, you can click on that. Well, most of us, I'm sure, do have binoculars. Then move straight across to the east, the left that is, and get the star Merak in Andromeda in your field view. And from there, move slowly up to a fairly bright star above Merak and continue to run up in the same direction until you'll find what appears to be a little cloud in the sky. That will be your stopping place, for you'll have found the Andromeda galaxy. And if you aren't familiar with these stars or the Pegasus constellation, you can always use a stargazing app to help you find the Andromeda galaxy. But put the phone away as soon as you've located it to let your eyes adjust to the dark night sky to ensure they can take in as much light from this distant city of stars as possible. In order for you to see it requires good eyesight and a dark, crystal clear night with no street or house lighting nearby. With the unaided eye, it appears as nothing more than an indefinite, mysterious glow, a diffuse, elongated cloud, perhaps 2 or 3 times the apparent width of the moon. The little cloud? The Andromeda galaxy was supposedly first noted by the Persian astronomer Abd al-Rahman al-Sufi, who described it as a little cloud in his book of fixed stars in 964 AD. But it may also have been known to Persian astronomers in what is now Iran as far back as 905 AD, or even earlier. An expert on star nomenclature, Richard Hinckley Allen, once reported that it also appeared on a Dutch star map from the year 1500. Galileo's rival, Simon Marius, is usually credited with the first telescopic observation of this object in December 1612. He described the nebula as an indefinite glow like a candle shining through the horn window of a lanthorn lantern, that is. A tremendous city of stars. Even today, binoculars and telescopes reveal this cloud, quote unquote, as little more than a smooth oval blur, which gradually brightens in the center to a star-like nucleus. And while it certainly looks larger and brighter than with our eyes alone, there is little to suggest the grandeur of this object, as it's often shown in long exposure observatory photographs. It's oval because from our vantage point, we're viewing it not far from edgewise, but in fact, it's nearly circular. Flat spiral assemblage of star clouds. The light from this little cloud, Andromeda, is actually the total accumulation of light from approximately 1 trillion stars. It's listed as Messier M31 in Charles Messier's famous catalog, Hazy Objects Resembling Comets, but later proved to be galaxies, nebula, or star clusters. And here's the most distant object that can be seen with the unaided eye. M31 has been estimated to be nearly 200,000 light years in diameter, or 1.5 times as wide as our Milky Way galaxy. Its bright nucleus is the hazy patch that is visible to the unaided eye. And like our own galaxy, M31 has several attendant satellite galaxies. 2 of these, is M32 and M110, can be picked out with low magnification in a small to medium-sized telescope in the same field of view as M31. There are yet 2 other smaller companions, NJC 147 and 185, which are much fainter and placed much farther away, close to the border of nearby Cassiopeia. starlight that traveled a long way. And as you look at Andromeda Galaxy tonight, you'll be doing something that no one else in the world except a stargazer can do. You'll actually be looking back into the distant past. There is a very good reason that this patch of light appears so very faint in the naked eye. When you see it tonight, consider that this light has been traveling some 2.5 billion years to reach you. So this light is 2.5 billion years old, traveling all this time at the tremendous velocity of 671 million miles per hour. The light you're seeing is around 25,000 centuries old and began its journey around the time of the dawn of human consciousness. And the light you are now getting is at least 480 times older than the pyramids. The distance it has traveled is so inconceivable that even to write the number of miles seems all but meaningless. And when it began its journey, 15 quintillion miles journeyed eastward. Mastodons and saber-toothed tigers roamed over much of the pre-ice age, North America, and prehistoric man was struggling for existence in what is now the Olduvai Gorge of East Africa. And this is actually just a neighbor of ours. With large observatory telescopes, we have observed galaxies that are over 1 billion light years away, or more than 400 times farther than Andromeda Galaxy. And then consider those galaxies that the James Webb Space Telescope is currently detecting. Light left some of them over 13 billion years ago, within just a few 100 million years of the Big Bang. Cosmic collisions of the past and the future? Recent studies indicate that about 6 billion years ago, the Andromeda Galaxy was breached by another large spiral galaxy. After several billion years, this intruder looped around Andromeda and finally smashed into its core and caused it to expand. Andromeda's satellite galaxy M32, a small compact elliptical galaxy, is thought to be the core of the renegade galaxy that collided with Andromeda. Initially, it was itself probably a spiral galaxy whose arms were stripped off by Andromeda's gravity. Interestingly, Andromeda is approaching our own Milky Way galaxy at a rate of 186,411 miles per second, and a galactic collision between our galaxy and Andromeda is now anticipated to occur in about 4.5 billion years. That's just about the time our sun will be going extinct. Based on current calculations, there's a 50% chance that in such a merged galaxy, our solar system will be swept out 3 times farther from the galactic core and its current distance. There is also a 12% chance that our solar system will be ejected from the newly merged galaxy sometime during the collision. What great news! Of course, that's cynical. This is all a moot point so far as life on Earth is concerned. In about 0.5 to 1.5 billion years, the sun's luminosity will have risen by 35 to 40%, likely initiating a runaway greenhouse effect on our planet. As a consequence, the surface of the Earth will have already become far too hot for liquid water to exist, ending all terrestrial life by the time the two galaxies collide. This is by Joe Rao, instructor and guest lecturer at New York Hayden Planetarium. He writes about astronomy for Natural History magazine, the Farmer's Almanac, and other publications. This was originally posted on space.com, and it's on Life Science. Please leave your comments, and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.